Hello, and welcome to Target 6C, Day 2. Alright, the definition I'd like to talk to you about today is a perpendicular bisector. A perpendicular bisector is a line that divides any given line segment into two halves, which means they have the exact same measurement, and forms a 90-degree angle at the intersection point. Just a quick tidbit, some of you might remember, this symbol stands for perpendicular. It shows that it's like an upside down T, and it kind of forms these two 90-degree angles. You may have seen the image with that too. Perpendicular bisector kind of adds on to that definition, and it gives the two sides on the bottom of that T shape the same exact measurement. So for example, if LN is a perpendicular bisector of MK, let's name the two right angles. We're going to have a right angle right here and right there. Notice how I am forming a box. That is how we indicate that an angle is particularly 90 degrees. Let's write down their names. We get angle LNK, LNM, and angle LNK. Both of these measure 90 degrees because it's perpendicular. Now the bisector part of this takes this bottom MK and splits it into two equal line segments. And we have MN and MK. They are the same measurement. All right, let's practice this again. Suppose CS is a perpendicular bisector of AE. Let's mark up the image so that we can name the line segments and the angles that are congruent. Well, first, when CS hits AE, it creates these two 90-degree angles, and it splits the bottom AE into two congruent sides. Well, what are the two congruent line segments? We get AS and we get ES. And the two congruent 90-degree angles that we get are angles CSA and angles CSE. Number 2. Suppose IO is perpendicular bisector to CS. Are there congruent triangles in the diagram? Explain your reasoning. Well, let's check it out. Let's mark up the image. Because it's perpendicular to CS, we get these two right angles. Angle, angle. Because it's a bisector, we get two congruent sides. CO and OS. And then we can use the reflexive property to label this side IO as another side. Are these two triangles congruent? Looks like they are by side angle side. Let's write down the statements and the reasoning. All right. First, I'm going to start with the sides on the bottom. We get CS is congruent to OS because IO by it's CO is congruent to OS because IO bisects CS. So IO cuts that line in perfect halves. Okay, next, let's talk about the angle. We got angle IOC congruent to angle IOS because IO is perpendicular to CS. When something is perpendicular, it creates a 90-degree angle. Lastly, we have that side in the middle, IO congruent to IO because reflexive property. Which allows us to say that triangle ICO is congruent to triangle ISO by side angle side. Number 3. For the following figure, Tim determines that the side PN and CB are congruent. Before I even continue reading, I'm just going to mark them. PN, CB. Cool. He also measures angle C and angle P and determines those are congruent. Fantastic. Thanks, Tim. whose name I changed to Steve in the middle of the problem, but that's okay. Let's mark it angle C, angle P. He concludes that the triangles are congruent by angle side angle. Is that enough information? Is Steve, aka Tim, I don't know why I typed it like that. I'll fix it for next year. Is Tim correct? Well, what do you think? Do we have an angle, a side, and another angle? No, we don't. No. He is missing the measures of angle N and angle B. Why do I say N and B? Because those are the angles that would create side, angle, side. Dang it, I meant to say angle, side, angle. I'm just going to blame it on seeing these side, angle, side right above. This is twice. I've done this twice recently where I have an angle, side, angle, and I look up at the side, angle, side, and I say that. Oh well. Anyways, onwards we go to number 4. I think that's our last one for today. For the following figure, Kevin determines that EK and AC are congruent. Let's mark it. EK, AC. He also measures, he measures angle K and angle C and finds out that they're congruent. Good. Angle K, angle C. Finally, he measures DK and CB. DK and CB and finds that they are congruent. He says that now it's congruent by side, angle, side. Is he correct? Yes, he is correct because he has everything that is needed. He has the measure. Oops. The measures of two sides and an angle in the right order for SAS. So he doesn't just have two sides and an angle. He has them specifically in the way that we want to organize two triangles, or we want to prove two triangles congruent by side, angle, side. Okay. If you have any questions about these, please let me know, or whoever else is helping you with math know. Otherwise, have a wonderful, wonderful rest of your day. Bye!